There is a fourth method for solving systems of equations using something called a matrix. A matrix is a way of organizing numbers together. In a matrix, we use brackets around a whole bunch of numbers. And we have rows and columns. Rows are the horizontal lines. Columns are the ones that go up and down. And the ones that we've done in class, we've either done a system of two equations, two unknowns, in which case we had a 2 by 3 matrix. That meant 2 rows and 3 columns. But I also introduced you to the 3 equations, 3 unknown system of equations, in which case we would have a 3 by 4 matrix. In order to solve a system using matrices, we need to use our graphing calculator. The function for matrices is under second x negative 1, which is on the left-hand side of your calculator. Then when you go to the matrix function, you arrow twice to the right to edit, and we're going to put our matrix into A. And you just hit enter. I should put enter here. Enter. Now, when you get to the matrix screen, where you actually type numbers in, there are 2 things you need to do. One of them is you have to tell the calculator the correct dimensions. If you're solving an equation with only, or a system with only 2 equations, you're going to use the dimensions 2 by 3. If you are solving a system that has 3 equations, you're going to use 3 by 4. Every time you type in a new number to enter into the matrix, you need to press enter to lock the number in, otherwise whatever value is already in there is not going to change. After you're done typing the numbers into the matrix, you're going to press second mode. That's quit. Then you have to go back into the matrix function a second time. So go back to second x negative 1, but this time arrow once to the right to math. And I want you to keep searching until you find RREF. It's not going to be on the initial screen. You're going to have to scroll down and it'll pop up in a second. RREF stands for something called reduced row echelon form. But all you need to remember is that it's the function that solves a system of equations for you, if the equations are in standard form. Then you press enter. Then you're going to go back into the matrix function one last time. But this time you're going to stay where you're at. You're going to be highlighted on names. And you'll probably have matrix A highlighted, and then you're just going to hit enter. So now on your screen it says this. You can close the parentheses if you want. You actually don't have to. It'll work either way. You press enter a last time, and then what'll end up popping up on your screen, depending on if you have a 2 by 3 or a 3 by 4 matrix, is something that looks like this. If you have a 2 by 3 matrix, you should have 1, 0, 0, 1. The final column will be your solution. The first number is x and the last number is y. If you have a 3 by 4 matrix that you're solving, the left-hand side of the matrix will say 1, 0, 0, 0, 1, 0, 0, 0, 1, and then your answers will be x, y, and z in that order. It's called an ordered triplet, as opposed to the ordered pair that you get with a 2 by 3 matrix. For one time and one time only, I'm going to show you how we algebraically solve a system of equations in 3 variables. And then we're going to go back to just doing it on the calculator using the matrix method. Alright, so the way this works is we're going to use a system of elimination. And we already know how elimination works. You add 2 equations together, one of the variables eliminates. Well, I want you to notice if I add the first 2 equations together, I'll call this equation 1, equation 2, and equation 3. If I add equations 1 and 2 together, the z's cancel. I'm left with 3x plus 2y equals 14. Then what I'm going to do is I'm going to add equations 2 and 3 together and eliminate a variable. But I have to eliminate the same variable, so it's got to be z. But right now I want you to notice the z's are the same sign. They're not opposites. I can fix that really easily. How about I do this? Negative, negative, positive, negative. Now they're opposites. So when I add equations 2 and 3 together, I get 3x minus 2y is equal to 3. All right, so now I have a system in 2 equations, which I do know how to solve. Of course, I have to go back 1 second. Sorry about that. That was not 14. That should have been 15. 4 plus 11 is 15. All right, now I'm going to solve this system in 2 variables using elimination. So I want you to notice the y's are already opposites. So when I add these together, I get 6x equals 18. So x is equal to 3. And if x equals 3, then I can find what y is by plugging into one of these 2 new equations. I can either plug it into the red one or the blue one. How about I plug it into the blue one? So 3 times x minus 2y equals 3. 6 minus 2y equals 3. Negative 2y is going to equal negative 3. And of course, I'm having all kinds of problems with my math here. Let's try this again. 3 times 3 is 9 last time I checked, so that's negative 6. All right. Now, when I divide, I'm going to get y is equal to 3. So I know x is 3. I know y is 3. In order to go back and find z, I'm going to plug it back into one of these 3 equations. And it doesn't matter which one I pick. How about I pick the first one just because it has a positive z? So 2 times x was 3 minus y was 3 plus z equals 4. 6 minus 3 plus z equals 4. 3 plus z equals 4. So z equals 1. So the answer to this system is x is 3, y is 3, z is 1. Now what if I wanted to do this exact same system using the matrix method on the calculator? Well, what you do is you put in the little matrix bars just the coefficients. So the first row would be just the numbers from the first equation. 2, negative 1, 1, 4. The second row would be 1, 3, negative 1, 11. And the third row would be 4, 1, negative 1, 14. Notice that when we put this into the calculator, we have to be in this form. ax plus by plus, we'll call it dz, is equal to c, and c is for constant. So all the first row are the coefficients of the x's. The second row are the coefficients of the y's. The third column is all the coefficients of z, and the last column are all the constants. So it has to be in that order, otherwise this does not work. You plug it into the calculator. It's a 3 by 4 matrix because there are 3 rows and 4 columns. When you use RREF, you should get 1, 0, 0, 0, 1, 0, 0, 0, 1, and the last column should be, what did we get for the answer? 3, 3, 1. So it should be 3, 3, 1. And that's what you should get. There's another way that the book sets up these matrices. So if you see a problem somewhere that looks like this, sometimes they write it where they have a little bar at the back end, or another way I've seen it written is like this, where they've written it as 2 matrices being multiplied. We'll talk about multiplying matrices next year in pre-calculus, but this is just a fancy schmancy way of saying one of the equations is 2x plus y equals 9, and the other equation is x minus 6y equals negative 1. So you can just pretend like you don't see the little bar, plug this into the calculator. Since this is 2 equations, 2 unknowns, this would be a 2 by 3 matrix. When you plug this into the calculator and perform the RREF function on it, you're going to get some nasty decimals, but that's okay. If you hit math enter, enter, it will turn those nasty decimals back into nice looking fractions. So you should find out that the solution to this system is 53 over 13, comma, 11 over 13. And that's how we use the graphing calculator to find systems of equations in either 2 or 3 variables using matrices.